Hi everybody, welcome to Pre-Calculus 5.1 Trigonometric Identities. The learning objectives of this lesson: identify and use basic trigonometric identities to find trigonometric values, use basic trigonometric identities to simplify and rewrite trigonometric expressions. Before we start, an identity is something that's true for all values. And the trigonometric identity is, an identity that involves trigonometric functions. The first set of identities are the reciprocal and quotient identities. Now, the reciprocal identities. So for any angle, sine theta is always 1 over cosecant theta. And cosecant theta is 1 over sine theta. Cosine theta is 1 over secant theta. And secant theta is 1 over cosine theta. Tangent theta equals 1 over cotangent theta, and cotangent theta is 1 over tangent theta. Now for quotient identities, you probably know this. Tangent theta equals sine theta over cosine theta, and cotangent theta equals cosine theta over sine theta. So we're going to use these identities to solve problems. Let's get to it. Our first example says if secant theta or secant x equals 5 over 3, find cosine x. Now, according to the reciprocal identities, we know that cosine, let me just make sure, cosine x or cosine theta equals 1 over secant x. Now, if secant x is 5 over 3, so this would be 1 over 5 over 3, which is 3 over 5. And that's it. Pause the video and try to do this yourself. Let's look at another example. If cosecant beta equals 25 over 7 and secant beta equals 25 over 24, find tangent beta. Now, we know that tangent beta equals sine beta over cosine beta. We don't have sine and cosine. What we have is cosecant and secant. Using the reciprocal identities, we can say that sine beta equals 1 over cosecant beta, which is 1 over 25 over 7 equals 7 over 25. Same thing for the secant. So cosine beta equals 1 over secant beta equals 1 over 25 over 24, which is 24 over 25. Now, tangent beta equal sine beta over cosine beta. Sine beta is 7 over 25 over cosine beta, which is 24 over 25. 25 cancel, so it's 7 over 24. Pause the video and try to do this yourself. Now for the second set of identities, or trigonometric identities, we have the Pythagorean identities. Sine square theta plus cosine square theta equals 1. Tangent square theta plus 1 equals secant theta, secant square theta. And cotangent square theta plus 1 equals cosecant square theta. So again, these are true for any angle theta. Let's look at an example. Now for this example, we want to find cosecant theta and tangent theta, given that cotangent theta equals minus 3 and it says cosine theta is less than 0. Now, if this is given, we know that in the unit circle, right here, cotangent is negative. Same here, cotangent is negative. And since cosine is negative, right here, cosine is negative. So we're talking about quadrant 2. Okay, this is very important. Now let's continue. According to the Pythagorean identities, we know that cotangent square theta plus 1 equals cosecant square theta. We have cotangent square, we have cotangent theta, so minus 3 square plus 1 equals cosecant square theta. 9 plus 1 equals cosecant square theta equals 10. And since we're in quadrant 2, right here, that means the cosecant and the sine should be positive. So cosecant theta equals plus square root of 10. Alright? Now to find the tangent theta, according to the quotient or reciprocal identity, tangent theta equals 1 over cotangent theta equals 1 over minus 3. So now we found cosecant and we found tangent of theta. Please pause and try to do this yourself. Try to understand which trigonometric identities we used and how we use them. It's very important that you memorize those identities. There's no way around that. Okay? Let's look at another example. We need to find cotangent x plus and secant x, given that sine x equals 1 over 6 and cosine x is positive. Now, since sine x is positive and cosine x is positive, we're looking at quadrant 1. Okay? Now let's start. We know that sine x equals 1 over 6. Using the Pythagorean identity, we can find cosine x, because sine squared x plus cosine squared x equals 1. Cosine squared x equals 1 minus sine squared x equals 1 minus 1 over 6 square 1 minus 1 over 36, which is 35 over 36. So cosine x, because it's positive, it's square root of that. 35 over 36 equals square root of 35 over 6. So we found cosine x. Using that, we can find secant x. Secant x equals 1 over cosine x, which is 1 over square root of 35 over 6 equals 6 over square root of 35, or 6 square root of 35 over 35. Okay? How to find cotangent. Let's do this here. Cotangent x using the quotient rule or quotient identity equals cosine x over sine x. Cosine x, we just found that, 35 square root of 35 over 6, over sine x, which was given 1 over 6 equals square root of 35. And that's it. Please pause the video and try to do this yourself again. Next, we're looking at the cofunction and the odd-even identities. For the cofunction identities, it says that sine theta equals cosine pi over 2 minus theta. Okay? And cosine theta equals sine pi over 2 minus theta. Tangent theta equals cotangent pi over 2 minus theta, and cotangent theta equals tangent pi over 2 minus theta. Secant theta equals cosecant pi over 2 minus theta, and cosecant theta equals secant theta pi over 2 minus theta. For the odd even, now the sine, cosecant, tangent, and cotangent are all odd functions. Cosine and secant are even functions. So sine minus theta equals minus sine theta. Cosecant minus theta equals minus cosecant theta. Cosine minus theta equals cosine theta. Secant minus theta equals secant theta. Tangent minus theta equals minus tangent theta. And cotangent minus theta equals minus cotangent theta. Let's see how we can use these in an exercise. Now let's look at this exercise. If sine x equals minus 0.37, find cosine x minus pi over 2. Now using the cofunction identities and odd even identities, we can do this. Let's start by looking at cosine x minus pi over 2. We know that cosine is an even function, which means cosine minus theta equals cosine theta. So we can say that cosine x minus pi over 2 equals cosine pi over 2 minus x. This one is the opposite of this, so they have the same cosine. Now at the same time, cosine pi over 2 minus x, according to the cofunction identities, equals sine x. Alright? Now we're given that sine x is minus 0.37. That means cosine pi over 2 minus x equals minus 0.37. And that's it. Please pause the video and try to do this yourself. Now to wrap up today's video, we looked at the trigonometric identities, which are true for all angles. We looked at the reciprocal identities, quotient identities, Pythagorean identities, cofunction identities, and odd-even identities. And we did some exercises involving those identities. Alright? Now, again, you have to memorize those identities. You're going to be using most of them. Some of them are used more frequently, but still you need to memorize all of them for now. Alright? Well, stay safe and we'll see you in the next video. Thank you.